students, welcome back to my lectures of class 12th physics. We are studying our chapter current, electricity. Here we have next topic, that is the relation between current and drift velocity. We have seen that what a drift velocity is. It is the velocity acquired by the charge carriers or the electrons when the potential or the electric field applied across the ends of the conductor. Okay, but what is current? We have not studied the current yet. So first of all, let us study that what actually a current is. What is current? We have studied this current in class 10th, that it is I is equals to Q by T, that is the rate of flow of charge, or you can say the time rate of flow of charge, that is called as electric current. Means here we have Q charge and time T, how much charge is flowing through time T in a conductor, that forms electric current. What is the unit of this electric current? Its unit is ampere. Now here, how can we define this ampere? This 1 ampere can be defined from the formula. Here, if I take this charge 1 coulomb and if I take this time 1 second, then I can define 1 ampere. So the current is said to be 1 ampere if 1 coulomb of charge flows in 1 second through the conductor. Then that current is said to be 1 ampere. Okay, now we have also a different type of current that is called as transient current. Okay, now what this transient current is? This transient current is a type of current which flows in a circuit for very short duration. मतलब जब हमारे पास कोई भी एक switch होता है, so whenever we are turning on or off this switch, then at that time the current which flows in the circuit, that is called as the transient current. इसको हम represent कर सकते हैं in terms of I0 plus or I0 minus. 0 plus, it means whenever we are just टर्निंग ऑन द स्विच, जैसे हमने इसको यहाँ पर ऑन किया तब यहाँ पर जो भी करंट फ्लो होगा फॉर दैट इंस्टेंट, दैट इज I0 प्लस एंड I0 माइनस. जैसे ही हम स्विच को ऑफ करते हैं, जैसे हमने इसको ऑफ किया, इन दैट केस एट दैट टाइम वट एवर द करंट फ्लोज, दैट करंट इज कॉल्ड एज I0 माइनस, दैट इज ऑल्सो द ट्रांजिएंट करंट. क्योंकि सपोज हमारे पास ये जो ग्राफ है, दिस रिप्रेजेंट्स द करंट, हियर इट रिप्रेजेंट्स टाइम एंड दिस इज करंट I. Okay, so in circuit, if we want that we should have maximum current, then to reach the maximum value of that current it takes some time. तो यहाँ पर क्या होता है, धीरे धीरे ये कुछ इस तरह से maximum हो जाता है. So up to here, to reach the maximum value of the current, this much time is taken by that current, and the value of this current is called as the transient current. Similarly, when we switch off the switch, in that case also this current reduces to 0 and it takes some time. So that will be 0 minus, and here it will be 0 plus. So such type of current is called as the transient current. Okay, now when we are talking about the current, we should also talk about the direction. हमारे पास इलेक्ट्रिक करंट का डायरेक्शन होता है, but we have two different types of direction. The first one is the conventional direction of current. Now what this conventional direction of current is? The conventional direction of current, it is the direction in which the positive charges flows in the circuit. अगर हमारे पास ये एक कंडक्टर है and in this conductor we have applied a battery across it. Okay, here this is positive charge, this is नेगेटिव, मतलब ये भी क्या हो जाएगा पॉजिटिव और ये भी क्या हो जाएगा नेगेटिव हो जाएगा. अब इस कंडक्टर के अंदर जो भी पॉजिटिवली चार्जेस पार्टिकल है वो कहां पर मूव करेंगे? दिस ऑल द पॉजिटिव चार्जेस पार्टिकल विल मूव टुवर्ड्स द नेगेटिव साइड बिकॉज दे विल बी अट्रैक्टेड टुवर्ड्स इट. तो यहां पर क्या हो जाएगा? दिस इज द डायरेक्शन ऑफ द कन्वेंशनल डायरेक्शन ऑफ द करंट. यू कैन से इट इज द डायरेक्शन ऑफ करंट इन विच पॉजिटिव चार्जेस flows, or you can also say this current always flows from positive side of the battery to the negative side of the battery. This is the conventional direction of current. Now here we have second type of current, that is electronic direction. Now what this electronic direction of current is? This electronic direction of current, it is the direction of current in which the electron moves. अगर इसी कंडक्टर के अंदर हमारे पास इलेक्ट्रॉन्स है, these negatively charged particles, they are the electrons. तो यहाँ पर ये जो इलेक्ट्रॉन है ये कहाँ पर मूव करेंगे? These electrons, because of this potential, they will move towards positive side because they will be attracted towards positive side. तो यहाँ पर जो इलेक्ट्रॉन्स है these will move towards the positive side of the battery. So this will move in this direction. Here also they will move in this direction. So here you can see that the direction, that is conventional direction, and the direction which is electronic direction, they are exactly opposite to each other. Okay, and whenever we are drawing any circuit, and that circuit, whenever we are representing the direction of current, then that direction of current should be conventional direction of current, that is from positive to negative side of the battery. Okay, now we have seen here the direction, that is conventional electronic direction. Now, is this current a scalar or a vector quantity? Now here, if we consider the current to be vector quantity, as we have this direction of current, so with the direction, if we can say that the करंट इज अ वेक्टर क्वांटिटी, देन अगर हमारे पास ये कुछ तीन कंडक्टर्स हैं, ओके, हियर वी हैव करंट I1, हियर वी हैव करंट I2, और यहाँ पर जो करंट है वो कितना है, मान लिया हमने I3. Now if I am considering this current to be vector quantity, then the angle between these two should affect the value of current. क्योंकि जब भी हमारे पास दो वेक्टर्स होते हैं which are inclined at an angle, then we have this a square plus b square plus 2ab cos theta. By this we are finding the resultant one that depends upon the angle theta. But here in case of the current, the resultant current that does not depend upon the angle in which the two wires are inclined. मतलब यहाँ पर जो दो वायर्स के बीच में एंगल थीटा है उस पे करंट का जो रिजल्टेंट वैल्यू है वो डिपेंड नहीं करती है. इसलिए यहाँ पर हमने करंट को क्या माना, द करंट इज अ स्केलर quantity. Why? Because the vector algebra is not applicable on the current, means this current does not depend upon the angle of inclination of the two wires. That's why the current is a scalar quantity and it's not a vector quantity. Okay, so this is all about the current. So now after looking at the current, we will derive a relation between the current and the drift velocity. So for this, let us consider that we have a conductor in which the electrons are drifting, that is they are moving with the drift velocity. Here I have applied here with the positive potential and on this side I have connected it with the negative potential. यहाँ पर इसकी जो length है, that length is L and the area of cross section is A, and I have applied a potential of V volt, and here the current flows in this direction. Okay, now here to find the relation between the current and the drift velocity, we have the relation I is equals to Q by T. That is the formula for electric current. That is the current is equals to time rate of flow of charge. Now here in this case we have to find the value of charge Q and the time T. Okay. Now first of all we will find the value of charge Q कि यहाँ पर total charge इस कंडक्टर के अंदर कितना होगा. Okay. So first of all let us consider here N be the electron density. Okay, and we are considering that it is the electron density. Now what is the electron density? So here I can write N is equals to number of electrons per unit volume. This N represents electron density. Electron density means the electrons which are present in the conductor per unit volume. So I can write this N is equals to number of electron upon volume. That volume of this conductor I can write simply area into length. So this is A into L. So I can write this total number of electrons by A into L is equals to electron density. So I can write here the number of electrons is equals to NaL. Equation number 1. Okay, this N is the, capital N is the number of electrons and small n is the electron density. Okay, now we also have Q is equals to Ne, that is from the quantization of charge. अगर हमें total charge निकालना हो, total number of electrons पता है और and charge on one electrons that is known to us, then we can find the charge. Now here I can also write here Q is equals to N into E. This N is the number of electrons और यहाँ पर number of electrons क्या है हमारे पास, capital N, इसलिए हमने यहाँ पर capital N use कर लिया है. Now here can I find the value of charge? Q is equals to value of N, NaLe. This is equation number 2. So in this way we can find the charge, that is charge which is in that conductor, that is NaLe. So we have got this value of Q. Now we will find the value of time T. So for time T, so here we have applied the potential V, and because of that potential there will be electric field across the ends, and because of that electric field the electrons will drift from negative side to positive side. तो यहाँ पर we have to calculate the time in which the electrons are reaching from negative terminal to positive terminal. So I can write this time is equals to distance upon speed, because we have speed equals distance upon time. So I can write this time is equal to distance upon speed. This distance, that is the distance of the conductor or the length of the conductor, and Vd is the velocity which is acquired by the electron while they are moving from negative to positive terminal. So I can write here this time and charge Q. So now I can put the value of T and Q in the equation A. So I can write using equation A, this I is equals to value of Q, NALE divided by L by VD. So I can write I is equals to, this L gets cancelled, it is NEAVD. So here we have the relation between current and the drift velocity, that is I equals to NEAVD. Now here we have this VD, that is the drift velocity, is equals to E tau by M. Here we are neglecting the negative sign. What is the meaning of negative sign? The negative sign represents that the drift velocity is opposite to the direction of electric field. So we will put the value of Vd here. So I can write this I is equals to NEA E tau by M. So I can write I is equals to NE square AE tau by M. So this is the value of current. Okay, so here this current, that depends upon the electron density, charge on electron, area of the conductor, electric field, the relaxation time and mass of the electron. And here this is the relation between current and the drift velocity. Now here we can also write the relation in terms of the mobility of electron. What is the mobility of electron? That is mobility of electron, that is the drift velocity per unit electric field. मतलब यहाँ पर जो Vd है इसको लिख सकता हूँ in terms of E and mu E. Now I can use this Vd here in this equation. So I can write I is equals to Ne A E mu E. So I can write I is equals to Ne A mu E. So this is the relation between current and the mobility. If you know the basic formula, that is the relation between I and mu d, then from that you can find the different relation. So this is the expression for the relation between electric current and the drift velocity.